if your function is y equals to tan inverse of x and you are being asked to differentiate the function, is it okay to say that if y is equals to tan inverse of x, then tan of y is equals to x? Can I say that,
Yeah.
right? So
Yeah.
if I would have taken tan inverse of x, I would have gotten the angle. So that means tan of this angle y is equal to x. Now, if you remember implicit differentiation, at a tan y, the differentiation is going to be, what was the differentiation of tan theta?
Um, let's see. God.
Secant square. Differentiation of tan x was secant square x, right?
Yeah.
Differentiation of tan x was secant square x. So differentiation of tan y is going to be
Secant y squared.
secant square y. Okay, but we know that y is a function of x. So this is a stage where you are going to use the concept of implicit differentiation. Secant square y, tangent y की differentiation is going to be secant square y times the derivative of y, which is dy by dx. Is the first step clear?
Yes,
Okay, just a second. All right. So differentiation of tangent y came out to be secant square y times dy by dx, and differentiation of x is going to be
uh, one, just nothing.
1. Right. Now, if I make dy by dx the subject, dy by dx will come out to be 1 over secant square y. Now, at this step, if you use the identity, secant square y is equals to 1 plus tan square y. I can replace secant square y with 1 plus tan square y. So this is going to be 1 upon 1 plus tan square y. 1 tan square y is same as saying 1 plus tangent of y, the whole thing square. And what was tangent of y equal to?
X.
X. So the last step is going to be 1 over 1 plus x square. So differentiation of tan inverse of x came out to be 1 upon 1 plus x square. Is this okay?
Yes, I'm just copying it.
Sure.
So I'm done copying.
All right. Now, what if there would have been a change in angle, a change in the value over inside the bracket? For example, if the question would have been that you need to differentiate with respect to x tan inverse of 3x, tan inverse of 3x. So I'm going to show you the similar working like we did over here. So I'm going to say, okay, the equation itself is y equals to tan inverse of 3x. Then that would mean that tangent y is going to be equal to 3x. And if I differentiate this, I'm going to get secant squared y times dy by dx, and differentiation of 3x is going to be 3. So dy by dx comes out to be 3 upon secant square y, and repeating the same step, secant square y can be written as 1 plus tan square y, 1 plus tan square y, which is same as saying 3 over 1 plus tan y the whole thing square. What was tan y equal to? What was
X?
tan y what was
Oh,
tan y tangent y equal to?
3x.
3x. So that would mean 3x the whole thing square. So the end result comes out to be 1 plus 9x square. Now, instead of going through all of this process, once you understand the process, you can make some observation over here and you can say the alternate method, alternate working is going to be you identify the form differentiation of tan inverse of x, tan inverse of differentiation of tan inverse of x was 1 upon 1 plus x squared. So whatever term is inside the bracket, you write this over here. So over here, if we had 3x, we are going to write 3x. But there is a 3 coming in the numerator, which is just the differentiation of the term inside the bracket. So your working could have been to differentiate this expression tan inverse of 3x. You're going to say the general form is going to be 1 upon 1 plus whatever is inside the bracket, that was 3x, the whole thing square. Multiply by the differentiation of the whatever is inside the bracket, that is 3. So instead of doing all the working, you can just leave your answer, you can just get your answer in 2 steps. This is more logical, and this is the observation that we can find the answer just from the observation. Is this clear?
Yes, sir.
Okay. You can note it down.
So I have it down now.
All right. So let's practice some questions, some more questions. If you are asked to differentiate tan inverse of square root of x, how would you do that?
First take x to the power of half.
So you can write this as tan inverse x to the power of half. Okay. So differentiation of this term is going to be
Is nothing?
The differentiation is going, see, the differentiation of tan inverse of x was in the form of 1 over 1 plus x square times the differentiation of x, which was 1. So similarly यहाँ पे भी 1 upon 1 plus,
X to
what
the
is the
power of
term? Yes, the term inside the bracket is going to be x to the power of half. Multiply by
the differentiation.
differentiation of
So
x to the power of half, that is
half x to the power of minus half.
exactly. So at the end, you're going to get 1. This is going to be simplified 1 over 2 root x times 1 plus x. Is that what you are going to get?
Yes, sir.
Part C, tan inverse of x upon x minus 2. Okay, try this on your own first. The question is to differentiate tan inverse of x upon x minus 2 with respect to x. All right. So the first step in differentiating tan inverse of x over x minus 2 is going to be 1 over 1 plus the term inside the bracket squared. So that is x upon x minus 2, the whole thing squared, times the differentiation of this fraction. And how do you think I should differentiate this fraction?
So do you make x minus 2 to the power of minus 1?
No, it's a fraction. Do you remember how to differentiate fraction?
Uh,
It was using the quotient rule.
oh yeah.
So if u is x and v is x minus 2, u prime is going to be 1, v prime is going to be 1 as well. vu prime, vu prime minus u v prime over v square, that is x minus 2, the whole thing square. ठीक है? Now, if you simplify this term, you should be getting, this is going to be 1 plus x square over x minus 2, the whole thing square. That is going to remain the same. I'll simplify the denominator. So x minus 2 the whole thing square plus x square. This is still going to be same. X minus x is 0 minus 2 over x minus 2 the whole thing square. Now you can reciprocate this fraction and you are going to get
So
x
how did you
minus
get the
2 the whole.
numerator as minus 2?
I'm sorry,
How did you get the numerator as minus 2?
minus 2. X minus 2 minus x. So
Oh,
if x and x are going to be cancelled out, minus 2 is going to be left.
yeah.
X minus 2 the whole thing square upon x minus 2 the whole thing square plus x square times negative 2 upon x minus 2 the whole thing square. I can simplify this and this, and the end result will come out to be minus 2 over x minus 2 the whole thing square. If you want, you can expand on this using the identity. This is going to be x square minus 4x plus 4, and then you have plus x square. Okay, I'm yeah, I will have this. I'm going to continue the working over here. Minus 2 over 2x square minus 4x plus 4. If I take 2 common from the denominator, I'm going to get x square minus 2x plus 2, and the final answer is going to be negative 1 over x square minus 2x plus 2. That is the simplified differentiation. Okay. Now, do you want more questions on this, or is it clear?
That's clear.
Okay. Copy this down. So try this last question on this differentiation. Find the equation of tangent to the curve y equals to tan inverse x upon 2 at the point where x is 2. Okay. So there's no new concept in the question. It's the similar question where you need to find the equation of the tangent to the curve at a particular point. And to find that, you need to differentiate this by tan inverse function. And we just did the differentiation of tan inverse. So you get the idea, right?
Yes,
So I would like you to try this out. Get me the right answer, please.
okay.
All right, so I'm going to display the solution now. So the first thing first, you need to differentiate the equation of the curve 1 over 1 plus x by 2, the whole thing square, times the differentiation of x by 2. So this gives us, I don't need to simplify this further. I can just plug in the value of x is 2 into the equation. dy by dx at x equals to 2. So 1 over 1 plus, when x is 2, this is going to be 1 times 1 upon 2. So are you getting gradient as 1 over 4?
So I was getting it as 5/4 for some reason.
Hmm. Acha. So if you just recall how we were differentiating it, differentiation of this expression is going to be 1 upon 1 plus whatever was inside the bracket, that is x upon 2, the whole thing square, times the differentiation of x upon 2, which is half. And
Okay.
then if you plug in x as 2, 2 over 2 is 1 square is 1 plus 1 is 2. So 1 upon 2 times 1 upon 2 comes out to be 1 upon 4. The next thing that we are going to do is find the y coordinate when x is 2. So tan inverse of 1 is
45 is
tan.
what I was.
You're going to, be careful when you're dealing with these questions, make sure your calculator is in radian mode. So
Oh,
what is tan inverse of 1?
0.7854.
Your calculator should be in radian mode. Tan inverse of 1 should be pi by 4, 45 degree over
Yeah.
there. So the point that we are looking at is 2 comma pi by 4. This is our gradient, and that's your point where the tangent is going, where the tangent is being made. So to find the equation of the tangent, all I need to do is use the equation of a straight line, y minus y1, which is pi by 4, equals to gradient, which is 1 upon 4 times x minus x1. 4y minus pi upon 4 equals to 1 upon 4 times x minus 2. So equation comes out to be 4 pi 4y equals to x minus 2 plus pi. Or either you can leave your answer like this, or you could write x minus 4 pi equals to 2 minus pi. Do you understand this now?
Yes, so.
Okay. Copy down the solution and let me know that.
I have it down now, so.
All right. What would you do if you were asked to differentiate this equation? What is the first step that comes to your mind?
Make it tan y equals to ex to the power ex times x.
But You see, e to the power of x is being multiplied by tan inverse of x. So whenever two functions were being multiplied and you were asked to differentiate this, how would
Use
you start
product rule.
differentiating? You're going to apply
Product rule.
product rule. Okay. So that is going to be a first step. If x is equals, sorry, your u can be e to the power of x and v can be tan inverse of x. U prime is going to be e to the power of x because we know that differentiation of exponential function is the same exponential function, and differentiation v prime is going to be 1 upon 1 plus x square. Now just apply the product rule and simplify this. Okay. Would you agree that it is going to be uv prime plus vu prime?
Yes.
So u is e to the power of x, v prime is 1 over 1 plus x square, plus v is tan inverse of x, and u prime is e to the power of x. You can take e to the power of x common, and you are going to get 1 over 1 plus x square plus tan inverse of x. That that should be your answer.
Yes, I
Similarly, you
got
could
that.
ask similarly you could ask to solve uh, uh, you could be asked to solve an expression that involves a fraction, and you are going to differentiate that using quotient rule. Okay? Would you like to try one question on quotient rule?
Okay.
Okay, chalo. इसको differentiate करो. So this is how you should be differentiating. Your u is going to be tan inverse of 2x and v is going to be x. U prime is going to be 1 over 1 plus 2x squared times 2. So 2 over 1 plus 4x squared. And v prime is going to be 1. dy by dx is going to be vu prime minus uv prime over v squared. v is x, u prime is 2 over 1 plus 4x squared minus u, which is tan inverse of 2x. v prime is 1 over v squared, that is x squared. So we can see how far we can simplify this. This is going to be 2x minus tan inverse of 2x times 1 plus 4x squared over x square times 1 plus 4x square. I have solved it directly. If you have any query in any of the steps, this is the final answer. So if you have any query, let me know. I first made the denominators common in the numerator, and
Yeah.
this term is going to be multiplied with this term reciprocal होने के बाद. So here we go.
Okay.
Let me know when you're done with this.
Oh, yes, I'm done.
Okay. So I think that's enough for this concept differentiation of tan inverse of x. Now I can start with integration. Now all of P1 integration needs to be known. Okay. We are going to study integration of some other functions such as uh, so basically just a second. अच्छा ठीक है. So in this chapter, basically we are going to learn how to integrate exponential functions because that isn't covered in P1. Logarithmic functions की integration, trig functions की integration, and we are going to learn how to apply integration to solve problems in this chapter. So the first thing that we are starting now is the integration of exponential function. Can you give me examples of exponential functions?
E to the power of x.
Exactly. E to the power of x is an exponential function. Now we know this that integration is a reverse process of differentiation. Okay. So the rules of integrating exponential functions are going to be if your function was e to the power of x in P1, uh, in P3 we studied in differentiation we studied that the differentiation of e to the power of x is just e to the power of x. So integration, if integration is the reverse process of differentiation, if I integrate this, I should get back my equation of the curve. So integration of functions such as exponential functions e to the power of x dx is nothing but e to the power of x itself plus c. Now understand this c is a constant of integration. You know this from P1 concept. So integration of e to the power of x is going to be e to the power of x plus c. And e to the power of any expression ax plus b dx. So in that case, you are going to eh, the integration of e to the power of ax plus b is going to be e to the power of ax plus b divided by the differentiation of the exponent, that is a, plus the constant of integration. So these are the rules to integrate exponential functions. Okay.
Yes.
If you just so if we know that integration is the reverse process of differentiation, अगर मेरे पास equation होती थी e to the power of ax plus b, तो इसकी differentiation क्या होती थी e to the power of ax plus b times a. तो अब अगर इसको integrate करूंगा, सही है? If you are going to integrate this, you are going to get this back. So let's see some examples. Integration of e to the power of 3x dx. What is the integration going to be?
E to the power of 3x plus c.
e to the power of 3x upon the differentiation of the power, that is 3 plus c. Then e to the power of minus 2x dx, the integration is going to be
E to the power of 2x upon minus 2 plus c.
e to the power of minus 2x upon minus 2 plus c. Correct? Integration of e to the power of 5x minus 4 dx.
E to the power of 5x minus 4 over 5 plus c.
Yeah, so e to the power of 5x minus 4 over 5 plus c. Okay? Then let's try another one. Do you remember plugging in the limits, upper limit and lower limit in P1? So
Uh,
you can evaluate. I'm talking about
oh
the
yeah,
definite integral. So 9 e
yes,
to the power of 3x minus 1 dx. First of all, we are going to integrate this, and then we are going to apply the limits in the integrand to find the final answer in exact form. So what is going to be the integration of this function?
9e to the power of 3x minus 1 over 3. So
Plus
3
c. Do you think
plus
I should write plus c? No, right?
c.
Because I already have the limits.
uh,
You're going to insert the upper limit first. So 3 e to the power of, you're going to insert 2 now. So 3 times 2 is 6, 6 minus 1 is 5, minus 3 e to the power of 3 times 1, 1, 3 minus 2, 2. Then you can take whatever you, so e square can be taken as common, 3 e to the power of 3 minus 1. Is that correct?
Yes, sir.
I can also take 3 common. I can take 3 e square common, and the answer is going to be 3 e square times e to the power of 3 minus 1. Done?
Yeah.
Do you remember solving for the area under the curve using integration?
Yeah.
So this curve has the equation of y equals to x square plus e to the power of negative 2x. The question is to find the area of the shaded region. What is the first step that comes to your mind?
Differentiate the curve.
You're going to you're going to
Differentiate the curve.
why would you differentiate the curve? Differentiating the curve will always give you the gradient expression. To find the area, we always integrate the curve.
Oh yeah.
Area, yeah, area is equal to the integration of the curve with respect to x. You can apply the limits on the x-axis. So the equation of the curve is x square plus e to the power of negative 2x. What are going to be the limits?
2 and 1.
Lower limit is going to be 1, upper limit is going to be 2. So I want you to integrate this expression and then plug in the limits to get the area. Okay? I'm just taking a break for 1 minute for the exam.
Okay.
Meanwhile, you can try this. So to integrate this, the integration of this is going to be x cubed upon 3 plus e to the power of minus 2x over negative 2, and the limits are 2 and 1. When you are going to insert 2, you are going to get 8 upon 3 minus 1 upon 2 e to the power of minus 4 minus 1 upon 3 minus 1 upon 2 e to the power of negative 2. And 8 over 3 minus 1 over 3 is 7 over 3 plus, this is second. So 7 over 3 minus, this should be your answer. Are you getting the same answer? This is the answer
Yeah,
in exact form.
but I took it, I simplified and made a decimal place then.
Okay, so what is the decimal value coming out?
2.392.
2.39. Yeah, okay. So this was integration of the exponential function. Now let's look at integration of integration of expression such as 1 over ax plus b. Okay, so to understand the integration of the expression 1 over ax plus b, let us first discuss the integration of 1 upon x. If you remember, in the if the function was ln x, what was the differentiation of ln x? Do you remember?
1 over 11?
It was 1 upon whatever was this bracket, 1 over x. Similarly, if it was y equals to ln, uh, let's say for example, ln ax plus b, then the differentiation of this was 1 upon ax plus b times the differentiation of this bracket, that is a. So the end result came out to be a upon ax plus b. So if we know that integration is the reverse process of differentiation, then let's integrate. Let's try to integrate this. Now I'm integrating. First I differentiated it. Let's try to integrate this further. So to integrate this, I'm going to take dx on that side. Now a is nothing but a constant value. So I'll have to take a on the other side, and it is going to be divided by 1. So on the right hand side, you are going to get ax plus b dx. So integration of this function 1 upon ax plus b dx is going to be equal to, I'm just swapping the side, 1 upon ax plus b dx की जो integration होगी, that is same as saying integration of 1 upon a dy. 1 upon a is just a value, constant value, and integration of 1 dy is y. So let's see. So 1 upon a, and what was y actually equal to?
ln x.
To start, ln ax plus b, right? So ln ax plus b. So what we understood now is that integration of 1 upon ax plus b is nothing but ln ax plus b over a. So the second rule is that if I need to find the integration of 1 over ax plus b, this is going to be equal to ln of ax plus b times divided by the differentiation of this bracket plus c. Is this idea clear?
Yes, sir.
Okay. So for example, integration of 1 over 3x plus 5 dx. What is the integration of 1 upon 3x plus 5 going to be?
1 over 3 ln 3x plus 5 plus c.
Ln of 3x plus 5 times 1 upon a. 1 upon a
1
is
upon 3.
3. Now, instead of teaching like this, what I also tell my students is okay, to identify where the integration is going to be equal to a form in ln, you just observe this. Okay, I'm going to do this example again. The denominator is 3x plus 5. What is the differentiation of what is the differentiation of 3x plus 5?
3.
3. Is that 3 present in the numerator?
No.
No. So if I multiply by 3 over here to to make the differentiation of the denominator comes in the numerator. Now this is something I'm doing on my own, so I'm going to time outside the bracket. I'm going to outside the integral sign. I'm going to multiply it by 1 upon 3. Now remember this, whenever you have the differentiation of the denominator in the numerator and you are being asked to integrate such functions, the answer is always going to be ln of the denominator. So I just accounted for this 1 upon 3 यहाँ पे. I'm going to repeat this step again. So the question was 1 upon 3x plus 5 की integration करनी है. 3x plus 5 की differentiation is 3, which is not present in the numerator. So I, I want the differentiation of the denominator in the numerator. So मैंने इसको multiply by 3 किया. Now this is, if I'm multiplying the numerator with a scalar quantity, I'll have to, outside the integral sign, I have to divide it as well. So 1 upon 3 मैंने बाहर कर दिया. So 1 upon 3. Now, whenever you have the differentiation of the denominator present in the numerator, the and you are being asked to integrate such functions, the integration is just going to be ln of the denominator. So this comes out to be ln 3x plus 5. Is this sort of clear?
Yes, sir.
Okay. So with the same logic, try this one. Integration of 1 upon minus 2x plus 3. Integration of 1 upon minus 2x plus 3. So it first of all identify the form. The form is 1 upon ax plus b. So for integration of these types of function was ln form. And what is going to be the differentiation of the denominator?
minus 2.
Minus 2. Is the differentiation of the numerator present in the numerator, differentiation of the denominator present in the numerator right now?
No.
So I'm going to multiply it by minus 2. Remember, this strategy only works for a scalar number. So minus 2. If अगर मैं numerator को minus 2 से multiply करूँगा, I'm going to get the differentiation of the new denominator in the numerator. But since this is something I'm doing on my own, to balance this, I have to divide it by minus 2 outside the integral sign. Now just focus on this. If if you have if you have the differentiation of the denominator present in the numerator, the integral is going to be ln of the denominator. Make sense?
Yes, sir.
Okay. Is there anything on the previous slide that you want to note down?
Also, I have it down.
Acha, one more thing. Since we are doing, uh, since the answer is an integral, the integrand is in the form of log ln format. So this expression is only going to be valid if this entire bracket is greater than 0. So if they ever ask you find the values of x for which this integral is going to be valid, what you are going to do is you are going to take this bracket expression and you are going to write it like this, that 3x plus 5 must be greater than 0 for this integral to be valid. So x must be greater than minus 5 by 3. They sometimes ask you for what value of x is this integral valid. So it is going to be valid when the expression associated with the ln is going to be greater than 0, because we have an understanding that ln of a negative number is not defined, ln of 0 is not defined. So for this integral to be defined, this bracket should always be a positive value. So bracket should be greater than 0, hence the value of x must be greater than minus 4 upon 3. Similarly, over here, this expression is only going to be valid when minus 2x plus 3 is greater than 0, or I can say 2x minus 3 is less than 0 and x is less than 3 upon 2. Does that make sense?
Yes, sir.
Okay, so let's do a question. For each of these integrals, find each of these integrals and state the values of x for which the integral is valid. Number A, integration of 2 upon x dx. So I want you to try with the first part. Integration of 4 upon 2x plus 1 dx. For the first part, what you are going to do, It is integration of 2 upon x dx. So if you take 2 outside the integral sign, you're going to get 1 upon dx. And what was the integration of 1 upon x?
ln
Ln of
uh,
x plus c. It's always better to write mod sign along with ln because we know that ln is not defined for a negative number. Now, the second part of this question was to find the values of x for which the integral is valid. For integral to be valid, this x should be greater than x should be greater than 0 for this to be valid. Okay? All right. Now, for the second part, integration of 4 upon 2x plus 1. First thing first, you can take 4 common out and you are going to get 1 upon 2x plus 1 dx. Now, you tell me, what is the next step that you have in your mind?
uh, you do 4 ln 2x plus 1 plus c.
But the differentiation of the denominator is not present in the numerator. So
Oh,
first of
so,
all, I'm going to multiply this by 2. Since I'm doing this up on my own, I'm going to divide by 2 as well. Now integration of such function is going to be 4 upon 2 is 2 ln of the denominator, that is 2x plus 1 plus c. This expression is going to be valid when 2x plus 1 is
greater than 0.
greater than 0. So x should be greater than minus 1 upon 2.
Okay.
Now try part C.
So I got minus 2 ln 2 minus 3x plus c.
Okay. So first of all, I can take 6 common. Then the differentiation of the denominator is minus 3. So I can divide this by minus 3 as well. The final answer is going to be minus 2 ln of 2 minus 3x plus c. And it's going to be valid for when 2 minus 3x is greater than 0, 3x is less than 2, x is less than 2 upon 3. Are you getting the same answer?
Yes, sir.
All right. Shall we move on?
Okay.
Okay. Acha, from your O-level math as well, do you recall this equation? What type of equation is this? Or what type of function is this?
Um, I'm not sure.
It's called a reciprocal function. Y equals to 1 upon x is a reciprocal function. And if I sketch this for you, the sketch looks something like this. For the positive values of x, you are going to get some sort of this curve. And for the negative value of x, you are going to get some sort of this type of curve. It's, this curve is just for the single equation 1 upon x. It's just that you can't have x as 0. That's why the function is discontinuous at the y-axis. When x is 0, the function is going to be undefined. Okay, and when y is 0, the function is also undefined. So the graph is not going to intersect the y-axis nor the x-axis. Neither this part is going to intersect the x-axis nor this part is going to intersect the y-axis. Is this clear till here?
Yes, sir.
Okay. Now, if I ask you to integrate 1 over x from 2 to 3, what do you understand with respect to the graph?
Um, inverse.
Integration of this curve when the limits are given is just going to give you the area under the graph from 2 to 3. So if this is 2 and this is 3, and if you integrate this curve from 2 to 3, you are going to get the area bounded by the curve and the x-axis. Remember, integration of the function gives the area bounded by the curve and the x-axis,
Yes.
right? Okay.
Yeah.
Now you can also observe from here that this type of graph is symmetrical. Like it's sort of symmetrical that this shape is identical to this shape. It's just that this is being made in the first quadrant, this is being made in the second quadrant. So i- would you agree that I'm going to get the same area if I would have integrated the curve from -2 to -3 as well? -2 is going to be somewhere over here. Let me draw this more clearly. -2, -3. It's because of the symmetry of the graph. Can you say that the two shaded areas are exactly the same? The area under the graph is going to be the same.
Yeah.
Yeah? Okay. So if I integrate 1 upon x function from 2 to 3, I'm going to get this area. If I integrate 1 upon x from -2 to -3, I'm going to get this area. The areas are going to be equal in value. Like in terms of magnitude, the areas are going to be the same.
Yeah.
They are going to be equal. It's just that when I'm going to integrate this part and apply the limits from -2 to -3, the answer of this is going to be a negative value. But I know that the area is not negative. It's just that the answer to this is going to be a negative value. So if I multiply the answer of this, since I know that this answer is negative, and if I multiply this with the negative sign, it's going to be positive, and the area is going to be equal to this area. So let's integrate them. I want you to integrate first 1 upon x and apply the limits from 2 to 3. What is the integration of 1 over x?
Ln x.
Ln x. If you apply the limits 3 to, you are going to get ln of 3 minus ln of 2. Do you remember logs rule? If the two logs having the same base are being subtracted, then how can you express the two logs as a single log? Ln 3 minus ln 2 is same as saying ln 3 upon 2. Do you remember this
Yes,
when
sir.
you were doing log chapter, right? So now let's evaluate this part. Ln x but the limits are minus 3 minus 2. So ln of negative 3 minus ln of negative 2, sorry, I made a small mistake over here. Minus 2 is basically the higher value and minus 3 is the lower value.
Yeah.
Okay, okay. So the upper limit is going to be minus 2 and the lower limit is minus 3. ln of negative 2 minus ln of negative 3. So this gives you ln of minus 2 upon minus 3, which is same as saying ln of 2 upon 3. Now, what is the difference between ln of 3 upon 2 and ln of 2, ln of 2 upon 3? Well, it's just if I multiply ln of 3 upon 2 with a negative sign, I can understand that these two areas are equal in magnitude. It's just that the answer to this integral is going to be negative of this, or this is going to be negative of this. So if I multiply ln 3 over 2 with the minus sign and using one of the rules of the log, this sign is going to go into the power and will be ln of 3 upon 2 to the power of minus 1. Now ln 3 upon 2 to the power of minus 1, if I just reciprocate it, it's going to be 2 upon 3. Hence, I get the same answer as this. So the two areas are, because of symmetry, the integration of 1 upon x from 2 to 3 is equals to the integration of minus from minus 2 to minus 3. It's just that the answers are going to be negative. The value is same, but it's just that the answer is negative. So to summarize this, I can say the summary is just that if I integrate 1 upon x from minus 3 to 2, minus 3 to minus 2, the answer is going to be negative of what the answer of 1 upon x key integration from 2 to 3 is going to be. Okay, that was the summary.
Okay.
Now, there, there is a reason why we always write ln of mod x as the integration of this, because we know that ln of a negative number is not defined. So if you pay close attention over here, ln of negative 2 is actually not defined. Mathematically, ln of negative 2 is not defined. So it's always better to write ln of negative 2 as just ln 2 and ln of negative 3 is just ln 3, right? Because these values are not defined. Ln of negative 2 is not defined. Ln of a negative number or a number equal to 0 is not defined. So that is why for for values of x less than 0, for values of x less than 0, I'm just going to say that integration of 1 upon x dx is equal to ln of mod of x. For positive values, I know it's going to be simply ln of x, but for negative, I'm just going to take ln of mod of x. Okay. All right. So try this question out. Find the value of integration of 6 upon 2 minus 3x from 2 to 3. Yeah, done with this part?
Yes, sir. Almost. Yeah, I'm done.
So when you apply the limit as 3, you are going to get minus 2 ln 2 minus 9 minus negative 2 ln 2 minus 6. Now you can see over here that uh, minus 2 ln 2 minus 9 is minus 7, but mod of minus 7 is going to give you 7 minus minus 2 ln 2 minus 6 is negative 4, and mod of negative 4 is going to be 4. That was the only catch. Minus 2 ln 7 plus 2 ln 4. If I just rearrange this, I'm going to get 2 ln 4 minus 2 ln 7. And if I take 2 common, I'm going to get ln 4 upon 7. Do you understand this?
Yes, sir. That's what I got.
Okay, perfect. So I'm going to stop today's class till here. And inshallah, in the next class, we are going to resume. I hope everything is clear to you.
Yes, sir.
Okay,
Thank
thank you.
you.
You're welcome.
Perfect. Thank you.
Okay.